Okay, so last week we dealt with exponentials and logarithms, and we're doing exactly the same thing today. All right, so if we remember last week, the equation that we used was something along the lines of P equals P naught times e to the kt. All right, but what we're going to deal with this week is exactly the same equation. All right, we're just going to be calling it different letters because we're going to be jumping into some financial math as we go along here. Okay. So comparing this to what we did last week, all right, we had the P, which was our final population, or the population of a certain amount. That is going to now be connecting to this A. All right, so this is P in our new equation. T, exactly the same, still time. R, we called it K last week, and then P now was our P naught from before, right? So this is your investment with P and your final amount with A. All right, and so let's look at an example here. We're going to be dealing with the principal investment of $1,000. Right, I'm going to write down our A is equal to our principal investment times E to the RT. Okay, we're going to have a principal investment of 1,000. We're going to have an interest rate of 0.06 and a time of 1 year. And all we're really going to do with a type of problem like this, right? This is our first type of problem, and all we do here is plug in what we know, right? So we know that A is going to equal our principal investment of 1,000 times E to our interest rate, which is always as a decimal, keep that in mind, so it was 0.06 for a 6% interest rate, times our T, which is just 1. Okay, and so as we do this, we just plug everything in our calculator and we get an approximation of about $1,000 and $1,061, sorry, and 84 cents. All right, so we made $64 or $61, sorry, over this 1 year investment, as opposed to a 6% would just be a $60 increase, right? So we're gaining more than just that 6% because of this compounding continuously, which we get from this PERT equation. All right, and so what we're going to do is why are we actually using this equation? Where does this come from a bit? All right, so we're going to drop down to this kind of table down here. All right, and the setup to this was, suppose that we went to a bank account and they said, hey, we're going to give you the best deal ever. We're going to give you 100% annual interest rate every year, and we're going to compound it different amounts. Okay, 100% for investing $1 for 1 year, just taking everything to its basic form. If we look at this first one, and based off that, this is where you would usually start with an Algebra 2 course, is we'd start with this equation here. But we're jumping straight to this PERT equation up here because that's what we're going to use more. All right, but based on this original equation, for annually, just compounding once, we'd plug 1 in, we'd get $2 after a $1 investment, right? If you get 100% investment, you get 100% back. You give $1, you get $1. All right, but if you compound twice, so halfway through the year, you get some of your investment back, and then you apply your interest to that investment you get back, right? So you're applying your interest on a higher amount. You actually get $2.25. All right, and what happens when you start filling this out if you go to quarterly, monthly, daily, right? So quarterly would be 4, monthly would be 12, daily would be 365, hourly was 8,760, and seconds, I actually changed to, if you look in your notes, minutes. I mainly do this because I like rent, and we can get 525,600 minutes are in a year. All right, and you would then, I'm not going to go through all these, you would then plug that in every single time, replacing this denominator with your new. So this one would be 1 plus 1 over 4 to the 4th. So you replace both of those. All right, and we see, all right, as we go through all these, okay, the next one is $2.61, 3, so a little bit more than $2.61. Next one's $2.71, right, so it goes up by another 10. All right, 71.4. This would be 2.718. The next one's actually still 2.718. So you have to add a little bit more. 2.7, and it goes on forever. All right, and so what this was Leonard Euler came up with this idea is, what happens if I compound infinitely many times? All right, and so we get this idea that, if you remember from the very beginning of the year, we talked about limits. But if we took the limit as n goes to infinity. In this case, n is the number of times compounding. Right? If we take the limit as n goes to infinity of 1 plus 1 over n to the nth power, that equals this number e, which is approximately 2.718. And what that allows us to get is, instead of using this 1 plus 1 over n equation, that gives us that PERT equation that we've already used, right, where the amount of money in our bank account is determined by our principal, P, times E, to our interest rate, times time. All right? Let's do just a couple problems. All right, this first one has been on pretty much every test that I've given, every final. Again, I don't know what our final is going to be or if we're going to have a final, but it's the same idea. All right, so we have an account. We invest $1,000 at a 5% interest rate, compounding continuously. So the first thing to notice is that this compounding continuously, that tells us we're using this PERT equation. All right, so we're going to use some kind of equation where we are A equals P times e to the RT. All right, where our P is 1,000. So we're going to get 1,000 times E. Our interest rate was 5%, so R is 0.05, right? We want to write it as a decimal. All right, let's go and write P was 1,000. So we have 0.05. All right, and we're just creating a formula based on T, so we don't know T yet, so that equals T, right? In this equation, now that we have a variable T, that's our only variable in this equation, we can write this as a function A of T, right? So I can know how much money I have based on time, right? So if I need 5 years, I'd plug 5 in for T. 6 years, like this next equation, I'd plug 6 in for T, right? So I'm looking for A of 6. How much money do I have after 6 years? Which is just 1,000 times E to the 0.05 times 6. All right, again, this is just going to be some calculator work. All right, there's not really much more involved here. I can give you some hints and tips, but bottom line, it's going to run down to, can you plug in your calculator? Most of the mistakes that are going to happen are going to come from this number right here, this 0.05. People usually put as 5, right? 5% on accident. So just make sure you're being careful. My suggestion when you're doing this is do this first part first, this e to the 0.05 times 6. Type that in your calculator, get an answer. Take that number, multiply it by 1,000, and you should approximately get, let me erase this weird smudge I made. You should approximately get, in this case, $1,349.86. Okay. So that's if you leave in there for 6 years, you make about $350, and at 5% interest rate. Which what you'll notice a lot of times is the interest rates we give in these problems are much larger than you get in the real world, just to make it easier to see the numbers. Right? If you really got it, would be a 0.5% interest rate, so our number up here would be 0.005. Not really easy to work with. All right, the next type of problem, which is one I really like, I guarantee if we have a test over this, which at this point I don't think we're going to have a test over this, but if we do, this next question will be in there. At the end of 6 years, what rate will we be growing at? Anytime you see a rate of growing, this is, again, our favorite thing in this class. We take the derivative. All right, so I'm actually looking for the derivative at 6 years, so I'm looking for a prime of 6. All right, so first I want to find what a prime of t is, and then I'll just plug in 6. The derivative, right, since we have an exponential, right, we're going to take the derivative of this equation that I'm circling now. All right, all we're going to do is the original equation stays pretty much exactly the same. It's going to be 1,000 times e to the 0.05 t. All right, and the derivative of the exponential, remember, all you do is multiply by the derivative of the exponent here. The derivative of our exponent is just the 0.05. Okay, and so our a prime of t, is actually going to give us 50 times e to the 0.05 t. All right, and that's how much money we're making each year based on the year, right? Because it depends on how much money we have in our account, depends on how long it's been. All right, so a prime of 6 is approximately $67.49 per year, right? That's each year that we're doing this, right? So if I went to 7 years, I'd probably be making $70 a year, or a little bit more, right? So every year the amount that you're making goes up because you're making it on more money. All right, this last problem is another one that's really good. What it does is it flips the switch, kind of. It says, well, now we have a amount. How long did it take? Right, so how many years will it require to double our investment? Well, to double, right, if we started off with $1,000 times e to the 0.05 times t, well, what's a double of 1,000? It's 2,000. Right, and so we're going to solve this equation, right? This actually has no calculus in it. This is just solving. Our first step with solving this is going to divide by 1,000. All right, and here's where we can get our first shortcut. All right, because what we end up with is an equation of 2 equals e to the 0.05 t. Okay, and we did these problems last time when we talked about finding the half-life. This is finding a half-life, basically, but finding a doubling life, I guess. And what we see is that this 2, okay, that corresponds to doubling. That doubled our investment. So you can actually just jump straight to this. You don't really even need to know how much you started with. Doubling it's going to be the same amount of time, right? You could start with $1 million. It's going to take the same amount of time to double as when you start $1,000. All right, so when we solve this, this is where we're going to use the natural log of both sides. So we end up with an equation of the natural log of 2 equals the natural log of e to the 0.05 t, all right, which is the natural log of 2 is equal to 0.05 times t. We divide both sides by the natural log, we divide both sides by 0.05. All right, and we get that time, or the time it takes to invest, is approximately 13.86 years. All right, this next type of problem is kind of the last one that we're going to deal with today. It's talking about present value. When we talk about present value, this is, again, just kind of turning this whole thing on your head. And it's saying, well, we know we're going to have $5,000. How much do we have to invest to get there? All right, so on this first one, we say, okay, well, we know A, or the final amount, is $5,000. We invested some principal at a 12% interest rate, and we did that for 2 years. All right, so we're just going to see solving in this case for P instead of A as we did before. All right, the nice thing about this is that it is all numbers, and again, there's no calculus, there's no solving. We just get e to the 0.24. All right, and this itself is just a number. All right, we can divide by it. All right, we get that P is approximately $3,933.14. Okay, saying that you have to invest around $4,000 to make $5,000. Okay, I'm going to leave these next couple problems, exercise 19 here, and then moving on, these back two problems. All right, go ahead and try on your own. They're exactly the same. They're going to give you 3 of the 4 pieces of information. You need to solve for the 4th. If you want to help, there is the answer key posted in the same announcement. You can use that to check your answers.